Hello, thank you for coming. My name is Hugo Daniel in Portuguese. And I'm going to talk about high-performance front-end development with React and Redux, but mostly about high-performance front-end development. I want to start by saying what this talk is not about. This talk is not about the perception of speed. This talk is not about those little actions that you allow the user to do so that he can feel a little bit comfortable while waiting, so that the waiting time seems a little bit shorter. This talk is not about that. This talk is also not about a set of tools, a set of actions, a set of good practices that you can use in your code in order to improve its performance. I'll give you some examples. This talk is not about the DevTools audits. So if you open your developer tools, you'll have this tab called the audits. If you press on it, you can generate some reports about your website, about the performance of it. This talk is not about that. This talk is also not about page speed insights. This is a web page by Google. I don't know if you're aware of it. So you can put your website and it will produce reports and give you a score and a set of good practices that you should be following and how you can fix several errors. This talk is not about that, but feel free to include it in your build environments by installing the PSI package. And whenever you build, it will produce this report for you automatically. But anyway, we'll just skip it. And this talk is also not about CSS reflow techniques. So, you know, those little CSS properties that you should be using instead of those others that will actually trigger a browser reflow or make things go slower. This talk is not about that. If you're into that, I highly recommend this website, csstriggers.com. This website has this huge table that you can search and see what you should be using instead of what you're actually using in CSS. This talk is also not about using map instead or for instead of map or what kind of functions are actually slower than others in JavaScript. For this, I highly recommend that you set your budget of performance for your application and use the benchmark.js alongside with your tests. This talk is also not about setting the node environments to production when doing a build with React. This is a common technique or good practice that you should be using. Set the node environments to production, and React will use a highly optimized build for your website or your application. This talk is also not about should component updates. For those of you who are familiar with React, this function is used to do some advanced performance techniques in React. Just read the fine manual of Facebook React and search for the advanced performance area and read it all. It's all there. Well, it's way more detailed than what I could possibly do here. This talk is also not about virtualization. For this, I recommend that you use React Virtualized or that you use the Facebook's own fixed data table. If you're doing some huge infinite data table and you know the exact size of each column. So this is a set of good practices. Look into these projects and use it if you're interested in that. This talk is also not about Redux optimizations. So things like, you know, instead of using just one store, use more than one store, do the connects to the below nodes of your React application instead of doing just one connect on top and everything just goes from that. This talk is not about that. It's not about how you can improve the comparison speed by using immutable JS. It's not about that. It's also not about memoization. If you really want that, I highly recommend Reselect. Reselect allows you to compute all the derived data from your state, and so your application will keep the minimum state available when it's running. So go check into that if you're into the memoization kind of performance techniques. It's also not about using observables to do all kinds of ninjutsu techniques with your asynchronous actions. I highly recommend the ReactiveX JS5 framework. There are some bundles for React that you can look into it. So what is this talk about? This talk is about going as fast as possible. And what is this? This is running in 60 frames per second. Why? Because this is the frame rate that your monitor, your computer screen, or your cell phone probably updates. So you will be running at this speed. And what does this mean? It means that you will have about 16.7 milliseconds for your code to run. If your code takes a little bit longer than this to run, then you'll be missing a frame and everything will seem slower. It's not that your brain can interpolate the frame we all know that movies run about 24 frames per second, most of them, and your brain actually does the interpolation for you. That's perfect, but at 60 frames per second, your brain does not have to do as much interpolation as it is necessary when watching a movie. But if you drop the frame rate, your brain will just, something happened here. There was a frame that was dropped. So it's very important for you to keep up with the 60 frames per second. And this is what this talk is about. It's about using request animation frame. This is a special function that will let you run code when the browser is starting to sync with the frame in your screen. So you pass it an argument to a function. So request animation frame, my function. And my function is run whenever the screen is updating. This is usually shortened to RAF. Like you can see this on the internet. So it means request animation frame. You can also Google for it as RAF techniques and stuff like that. You'll find it. So let's think about it. What is the fastest function that I can run in request animation frame? It's easy. It's a no-op. It's a function that does absolutely nothing at all. What this function that we see here is doing is nothing at all. It's just calling itself over and over again, 60 frames per second, blah, 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 doing nothing happily ever after until it dies somewhere in space. How can we measure it? We're going to measure it using the Performance API. This is a special API that your browser has that will allow you to set some marks and then compare the time that was spent between those marks. We'll use this function, the mark. For each mark, we'll specify a name, and then we'll measure them. We can have several measures. We'll just do once. For each measure, we can also say a name. This is my measure number 4. And for each measure, we also say the start and end of the mark. This will give us the time spent between those marks. It's magic. Like the browser keeps all these timing buffers, these timestamps for you. You don't have to handle any of it. Just place some marks on your code and see how much time is spent. In the end, you get all the entries, all your measures, and check it out and produce it in some sort of output. We'll be using console log. So let's make it a little bit funny. In our simplest function ever, we are going to count the frames. And after 120 frames, we want to see how much time was spent. Say, if we're running at 60 frames per second, 120 frames should give us about 2 seconds of runtime, which is 2,000 milliseconds. Here we are doing this. We are just counting the frames, adding them up. And when, like you see this if here, when we get to 120, we place a mark. 120 was reached. Before we start, we place the mark 0, and then we call request animation frame in our function. Everything goes fine. But we also need to set the timeout. The set timeout is important. So we'll be running this, and after, say, 3 seconds, should give enough time for our code to run. I hope it does not run as slow as 3 seconds. We are pointing to 2 seconds runtime. After 3 seconds, let's just, produce here the output log. We can see here I'm using measure, giving the name to my measure, and then calling the names of the 2 measures I really want, the beginning and the end. Check out, I'm going to output in the console log, and just to give you an idea before we go, this is the whole code. I will not be showing the set timeout anymore, so this will always be present along our examples. So just make sure you get it. So we're running the simplest code as possible in each request animation frame. It should be running in about 2 seconds because we're targeting to 120 frames. We're counting that time. And when we print it, it goes something like this. 120 frames in 2,148 milliseconds. This sucks. This is really bad. Why is it running above the expected time? It should be running below. After all, I'm not doing anything. Something is wrong here. So this is not cool, It's like 80% above the limit, which makes it running closer to 55 frames per second. How can we understand what's going on? Let's open the developer tools and see the performance log of all of this amazing function that does nothing at all. So this is the performance log. I recorded it. And if we take a good notice, like our average is 55 frames per second, just like we were expecting it to be according to the measuring times that we already did. Also of note is the maximum frames. We're running at 60 frames per second in our best case, but our minimal is only 5. So this is not cool. Also, if you can take a notice, along these red dots, there are huge drops of performance. This is also not cool. Why is that? If you look at the tree of invocations, you can see that there are 95% of the time is spent in Gecko, this kind of Gecko process. There's nothing we can do about it. Just live with it. This is actually not a performance handicap. But after this, we're spending almost 3.5% in garbage collecting. So something is going on. Those red dots are the garbage collecting doing its stuff. Also below, if you take a good notice, you will see also again the garbage collecting in the nursery. What is this? What does this mean? Let's talk a little bit about the garbage collector. The garbage collector is like this process that the browser has that sometimes runs and completely screws your performance. It completely screws your code. The JavaScript is a garbage collected language. You should have to learn with this, to live with this, if you want to achieve high performance results. Let's see. Garbage collector in browsers is usually what is called a generational garbage collector. This means that it has two different kinds of buffers, a nursery buffer and the tenured buffer. The nursery buffer is where all your most recent objects go. The tenured buffer is where all your old objects go. So, you create an object, it will go to the nursery. After a while, if your object keeps getting used a lot, it is promoted to the tenureds. And the tenured buffer is better because the browser will not need to run garbage collector as often. How can we avoid garbage? We can avoid garbage using a simple of JS techniques. Say, avoid allocations. This is very important. Reuse as much as you can. Whenever you call something like new object, new array, new string, new whatever, you're doing an allocation. You're just like, hey, I need this variable. But then, don't say anything to the garbage collector. And the garbage collector, use it at all. I'll just clean it afterward when I want. When I want, I will kick in, screw your code, screw your performance, and clean it up. And you're just like, come on, man. Another thing is functions. Whenever you declare a function, you're doing an allocation. Functions in JavaScript are just special objects. So you're just calling new object, and it's an object that you can run. So pay special attention when you're like creating functions during your runtime, because that's like saying to the garbage collector, here, I'm putting lots of stuff in my nursery heap, and then you'll need to clean it up afterwards when I really need the performance. You know, Moore's Law or something like that. Another thing that's also very tricky to do is strings, arrays, objects, things that are declared, things that are declared like this. This is tricky because you will never notice. You're actually allocating stuff, and the garbage collector is taking a note of that, and he will come to destroy your performance. Another thing is arrays push. If you do a push into array, you think, this is a really fast operation. I'm running at like light speed with my code. I'm doing array pushes. I'm the best. No, you're not. You're screwing your performance because the garbage collector will come in and completely nullify your code. So how can we change the code we've seen before to use these kind of techniques? Well, my first approach, here is the code again so that you can remember it. My first approach would be to use a closure. Why a closure? If we wrap our fastest function inside the closure, we're creating an environment that lives during the whole time of the execution of our loop. Because beforehand, if you look at this, we're just like creating a function, then calling it, then it runs, it stops running, then calling it again when the frame goes up again, then stops running, calling it again. Maybe the browser does not understand that we're going to need this function forever. So just wrap it in a closure and define it to make sure that it goes directly to tenured heap. And the browser understands that we'll be needing and using this function for the whole time of our code execution. How do we do that? We use a simple JavaScript technique called immediately invocation function. You can see below here, IIF. So we wrap it all here in function. And then, in the end, we immediately call it. As soon as the code interprets this, our JavaScript interprets this, it calls it, and everything inside it will live forever. So our variables will go to the tenured heap. Notice that we're also not calling the request animation frame. We're just calling it here. Also notice that we have not changed the code of our fastest function. And in this code, you can see that we have some allocations, like here. This is doing an allocation. It shouldn't be doing. We want high-performance code. So this is not a good practice. I don't know if this is doing an allocation, but let's just remove it anyway, this 120. And this, well, I sincerely hope that the JavaScript can optimize this because it's just incrementing by 1. So if we do all of these optimizations, what we have is something like this. So this is the code. We put all our variables here and reutilize them in our fastest loop. What we are doing, see, in the if, we are like comparing with limit, which is this 120. And when we place the mark, we are not allocating because the allocation was done here before the loop function. And since this allocation was done in our closure, and our closure lives forever, the Java engine will probably understand that this is a long time allocated object. It will go into the tenured heap. So the garbage collector will not mess with our code. That's what I hope. So let's see. If we run this, also remember that the set timeout is always present. If we run this, what we get, and boom, 120 frames under 2,000 milliseconds. This means that our code is running below the threshold, below the limit of our 60 frames per second. It's giving even more time to the browser to think and do its things. This is perfect. Let's look into the developer tools, performance, and analyze it. Here it is. So, for starters, the average is a little bit higher, which is very good for us. Then, you can see that the minimum is actually almost 40 frames per second. This is actually very good, so the user will not be running at 5 frames whenever the performance drops. We also note that there are no more garbage collection allocations in our runtime, in our call tree. This is very good. Look, the slowest thing we have is like this 0.9%. That is something called about events and stuff. So we're like completely removed the garbage collector. At least that's what we think. If we look carefully, you can see that there are still red dots over there. Why are these red dots happening? These red dots are a special kind of garbage collector. It's like the Nazi of garbage collectors. It's called the cycle counter. The cycle counter is the worst. If you ever mess with the cycle counter, you will lose. You will lose forever. Because the cycle counter, what it does is it runs through your code and checks if there are variables that are pointing to each other, like a cycle of references that the garbage collector never can catch. And so you're always incrementing memory, always keeping live references, and you're not using them, but they are there, pointing to each other, and the garbage collector needs to run and try to catch all of these little cycle references. This is what the cycle counter does. It goes through your code, checks for this, and to do that, it must stop everything. It must run like only me running, only me checking out the code, no more referencing, doing stuff elsewhere. So it's like you can't avoid this, especially in our very simple code. I don't think there's any way to avoid this. The good thing is that the cycle counter is very fast. So those little red dots are actually not hurting our performance as much. Now, all of this just for a simple loop. Why? The answer is because I need better hardware. My graphics card is very slow. If you type this address in Chrome, it will give you a report for your graphics card. And in my case, it just says, you know, forget it. Yeah, some GPUs can perform poorly, disable all, blah, 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 blah. Forget this graphics card. You shouldn't be using this, but I am. So it's good for tests. It's good to understand these kind of things that happen once in a while, and why is my code running so slow. But you need to be aware that JavaScript runs in a single main thread, and it still has to find time to paint. It still has to find time to draw all your web page. It still has to find time to do all those little animations that you want. After all that is done, it gives you time in your request animation frame. Only after that, after or before. Sometimes it depends. Request animation frame gets called sometimes after, sometimes before. I haven't been able to understand this. So let's see. How does the browser work? First, the browser constructs the DOM. We all know this. The DOM is the result of parsing your HTML. And the DOM will produce some nodes. Some of these nodes are special nodes and get delivered to a special render function, like video, like SVG. SVG nodes usually get delivered to a special SVG renderer. Can be very slow or can be very fast. It depends in some cases. But most of the time, the browser will handle your DOM and will render it. Also, next to it is the CSS OM. It's like the object model of CSS. All your colors, all your stuff, it will get into a tree like this. In the end, the browser merges these two trees and produces what is called the render tree. The render tree is like a set of orders for the browser to render. How can we handle reflows? And how do reflows happen here? Sorry. Whenever we change a DOM, the browser will have to merge everything, recalculate everything again, produce the render tree, and paint the stuff again. It's very slow. So how can we handle it? There are several techniques. One very old technique is to use request animation frame, batch all your DOM differences and changes, and do it in the vsync. So in that way, whenever you're going to do a vsync, the browser will already have a cached set of actions to do in the DOM, to perform in the DOM, and it will do them. There's also a library for this called the fast DOM. It's very famous. And I also did a library for this called pardom. Here is in NPM. It's slightly different than fast DOM, as it allows you to run actions in parallel, like all your logic, all your code runs in web workers, and then whenever you need to go to the DOM, it will catch all those messages and perform them in the request animation frame. So your code is actually running inside the web workers, and all the DOM actions are done in the main thread. And then there's React with Virtual DOM and many other projects that use many different types of Virtual DOM. How does this work? You probably know this. You know, a tree of components, like list component with a bunch of items. React produces a set of React elements, which is like the DOM virtualized. So this will completely destroy your memory of your browser. So be aware, don't push too much of it. And these React elements then get pushed to the DOM. React will then listen to events on the DOM. It will do this using some optimizations. And whenever an event action happens, like a click, React will actually pass this event to a function into your components, and then again to the virtual DOM, and again to the DOM, and forever. So this got a bit messy. People started, you know, we have lots of state. We need to handle all of this state. How are we going to do this? Facebook invented Flux architecture, and then lots of libraries showed up, and then Redux showed up. Redux, probably all of you know about this. I'll just give a small intro. You start with the initial state of your application, and then you don't keep any more states. What you keep is a set of transformations. Say, you have a game, your player dies. There's an action, player dies. And you get state 1 here, S1. Then some other action happens, and you go to state 2. You're not keeping any state, only the transformations that happen on the initial state. That's the thing that you're keeping. What this does is it allows you to time travel. Say, if you're here and you want to go to state 2, you just remove this action. It's easy, you don't need to keep up with a lot of stuff, and it's great. It also allows you to keep middlewares. Say, whenever an action is about to happen, you can run your code, do some stuff, and then call it again with whatever, change the stuff. So this is like, you can actually code between how the actions get mapped to the state. It's really good. Now I want to talk to you about React's best feature. This is, in my opinion, the best feature of React is this. Very simple. Here. It's the React DOM render. It actually allows you to use React only in certain DOM nodes. So, if you're doing a full-page application, this will probably not be a good thing because you'll be using React in all of your web page. But if you're only using React for certain areas of your DOM, you can do it. And you can even only use it for the slow parts and do the high-speed parts in other parts of your code. So here, content is where our React code will live. Say, if we have like a canvas DOM node, and we want to use high optimization on it, like 60 frames per second, blah, 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 React is probably not a good thing to use, because React will do all of that virtual DOM cycle rendering. So you should probably keep it like somewhere in your DOM node and use React outside of it. Good thing about Redux is that you can avoid the render loop. How? You just code your own middleware, and in your middleware, you just interact with your critical code. Say, again, the canvas. Canvas is very impure stuff. You cannot recreate the state of a canvas by going up and down in the set of transformations, because it's impure by nature. It was not well designed. It was designed to be fast. It was designed to be ugly. If you want a proof of that, just look at the amount of libraries that have been released about Canvas. There are tons of them, and they help you like with speed, with usability. So Canvas is a good example of like an API that you should probably be using this and not using only React to handle the Canvas. You'll be losing a lot of frames there. The virtual DOM needs to be checked and needs to be diffed, and it will be very bad. So look for a middleware in your Redux that actually communicates with the other part of the DOM that your code is not using, the critical part of your DOM. Take it out of React, put it elsewhere, and use pure JavaScript. Nothing beats pure JavaScript in performance. I'm also going to plug a little middleware I did called Redux Canvas. This is not actually a Redux middleware only for Canvas. You can use it for whatever projects you want. You can keep several different contexts of execution, and you can also communicate back and forward, and it will batch them all in the request animation frame, all in parallel with React. You can use it if you want, or if you don't want. There's a set of tests and examples. Just look into it. And with this, I will finish my talk. I hope that you have enjoyed. Here are some credits for the photos. It would not have been possible without this. And my contacts. Now I will just ask for questions. Any questions? Yeah.
My question here is about JS and all those optimizations that one can do.
Yeah.
And where do I find docs that can expose those type of optimizations?
Yeah, there are some documents out there. There's a set of V8. Oh, sorry, let me just repeat the question. The question is about, it's okay? Yeah. So there are some documents about that. You can look for V8. I don't know the name of the link exactly, but like V8 under optimizations, I think it's something like that. It's a GitHub page with lots of things that you should not be doing in JS if you care about performance in V8. About JavaScript, about Mozilla, my best recommendation is their developer channel. They have lots of videos about garbage collector, about their engine, about optimizations. It's a little bit more boring, so you have to watch the videos, and the presenters are usually, they are coders, and they speak a lot about code, very technical videos, but still a very good place to learn about all of those. And then, tests, Stack Overflow, all those usual places, Google, yeah. Did I answer your question? No, thank you. Any more questions? No? Okay, I think we're done. I hope that you enjoyed, and have a good time. Yeah.